Lesson 2, Module 4, continues with our understanding of dividing fractions by showing models as well as using the linear approach. So your objective for this lesson is that you can use fraction bars and area models to divide fraction by fraction. So we have a 3/4 in our example divided by 2/3. So using the approach that we've already learned, keep 3/4, change to multiplication, flip to the reciprocal. Then multiplying straight across, and again, reciprocal is just when you flip your fraction over, so instead of 2/3, it's 3/2. 3 times 3 is 9, 4 times 2 is 8, we get 9/8. 9 divided by 8 is 1, with a remainder 1, so it's 1 and 1/8. Now, using a number line, you can do this. I know I've shown you how to do it with the blocks. This is kind of the same idea, just instead of blocking it off with each 1/12, I just left it open. So the reason I had to do a 12 is because I had to look at my denominators here, 4 and 3, and find the common denominator, or the least common multiple. So 4, 8, 12, and then that'd be 3, 6, 9, 12. So the first number they share in their multiples is 12, so their common denominator I used was 12. But then what I had to do was take my fraction and convert it to an equivalent fraction by multiplying them by the same number. So 4 times 3 gave me 12, so I had to take 3 times 3, because in order, just like with our ratios, in order to create an equivalent fraction, we have to do the same thing to both numbers in the fraction. So my 3 times 3 was 9, 4 times 3 is 12. Had to do the same thing over here, but I needed my denominator to be 12, so I had to take my 3 times 4 to get 12, which would be 2 times 4, which gave me 8. So then my new division problem with the common denominators was 9/12 divided by 8/12. The reason this is going to work is because with equivalent fractions, just like equivalent ratios, once we simplify them down, you're working with the exact same fraction. So the division between equivalent fractions of these will still give you the same answer. Since 12 is my denominator, I went ahead and created a number line with 1/12, just like if I created a box and had 12 boxes in it, showing you 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12. We only have 9/12, so that's where we started. Now I want to figure out how many 8/12 we had, so I was counting them. So that is 1, 2, 3, 4, 5, 6, 7, 8. Right there, that's 8/12. So I have one of them, or I have 8 out of the 8/12. Then what's left then, or what I have left, for my 8/12, I only have 1 out of the 8/12. So that's the 1/8. And so that is why we have 8/8, so that's a 1, and then we have 1/8, because I was looking for 8/12, but I only had 1/12 inside the 9/12, is why the 1/12 is there. So the answer is 1 and 1/12, and that's why on a number line. Lesson 4 is continuing with the interpreting and commuting division of fractions by fractions and using more models. So we're looking at writing at least 3 equivalent fractions for each fraction below. In order to do an equivalent fraction, it's the same idea as an equivalent ratio. We have to multiply or divide, and again, this is for equivalent fractions, multiply or divide the numerator and denominator by the same number. So I have 2/3. I can't divide 2/3, so I'm just going to multiply it by the same. I'm going to take 2 times 2 and 3 times 2. That's going to give me 4/6. And then I'm going to take 2/3 and I'm going to multiply both by 3, and I'm going to get 6/9. And because it asks for 3, I'm going to do one more. I'm going to take 2/3. I'm going to take them both times 5. And that's going to give me 10/15. So 2/3 is equal to 4/6, and is equal to 6/9, and is equal to 10/15. Doing the same thing for B. I'm going to take, 10 and 12 are both even, so that means I can divide them both by the same number. So I'm going to start with dividing both of them by 2. And that gives me 5/6. And then I'm going to take 10/12. I'm going to multiply them both by 2. And that gives me 20/24. And then I'm going to take 10/12 again, and I'll multiply both by 3. And that gives me 30/36. And so 10/12 is equivalent to 5/6 and 20/24 and 30/36. So that allows us to simplify fractions when we need to, understanding how the equivalent fractions work. So let's go ahead and look here at example 1. The question is, Molly has 1 3/8 cups, so this is what she has. She needs 3/8, this is what she needs. So needs, has. How many batches can Molly make? So we have to start with what we have. What she has is 1 3/8. What we need is 3/8. So we're going to divide by 3/8. Now, in order to do keep, change, flip, they both have to be in the fraction model or in the fraction form. So I have 1 3/8. I'm going to create a improper fraction. I'm going to take 8 times 1 gives me 8, plus 3 gives me an 11. So that's an 11/8 divided by 3/8. And then I'm going to do my keep. That's 11/8 change to multiplication and flip it over to 8/3. You have 11 times 8, which is 88. And you have 8 times 3, which is 24. Remember, 88 over 24 is the same as 88 divided by 24. And 24 can go into 88 3 times. And that gives you, I believe, 82. 3 times 4 is 12. It'd be 72. Carry your 1. So you get 72. I subtract. That's going to be, I have to borrow. That becomes a 7. That's an 18. So we get 16. So we have a remainder 16, which means this would be a 3. And 16, the denominator is 24ths. Both of these can be divided by 8. And so we get 3 and 2/3. Now, the model that goes with it, we're working with 11/8, so I need to do 11/8. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. So this is my whole. And then I have an additional 3/8 with it. So that's 1, 2, 3. So these are all 1/8. Yeah, probably should have written it bigger so you could see those are each 1/8, but these are all 1/8. Let me actually do that for you so that you can see it and use it as a reference on any quizzes or future problems that we do. So 1/8, 1/8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1, 2, 3, 4, 5, 6, 7, 8 is a whole. So this is the 1, because that's 8/8. 1, 2, 3, 4, 5, 6, 7, 8. So this is our 8/8, and then the 3/8 that are left over, or the 1 and 3/8. So then we were dividing by 3/8. So they wanted to see how many 3/8 there were. So here's 1. That's 2. That's 3. And then you have 2 out of 3/8, which is 2 out of 3. So that's my 2/3. So that's 1, 2, 3 of them. And then the 2/3 that were left. And that's how the model works. On to example 2. We have 11/8 cup of strawberries. So this is what she has. This is what she needs. We start with what she has, and we divide by what she needs. Again, we have to do keep, and then we have to change it to multiplication, and then we flip it over to 4/3 and multiply straight across. 11 times 4 is 44. 8 times 3 is 24. And then we have to simplify this. So 44 divided by 24, I know it's going to be a 1 because 24 times 2 is 48, and 44 is less than that. So then I just need to subtract to find out what will go in my fraction. So it goes in there once. I have a 24. That gives me a 20 as the remainder. So that would be a 20/24. But 20 and 24 both have a common factor. Their greatest common factor would be a 4. So I'm going to divide both of them by 4. And I'm going to get 1 and 5/8. 5/6. So you have to create your model. Again, we have 11/8. And I'll draw that in there for you. And then they want to see how many 3/4 they have. Well, I look at this, I'm like, well, this is an 8. So what do I need to do to 3/4 to figure out how many 8ths that would be? I have to create an equivalent fraction. So I have 3/4 and I need it to equal something in 8ths so I know what the groupings are. And that means I have to take 4 times 2. And the rule for finding equivalent fractions is that you have to do the same thing to both. So that would be a 3 times 2. That would be 6/8. So they want to know how many 6/8 there are in the 11/8. So I'm going to count out 6. 1, 2, 3, 4, 5, 6. So that's 1 6/8. And then 1, 2, 3, 4, 5. I only have 5 out of the 6. So that's 5 out of the 6/8. And so that would be my 1. That's 6 out of the 6/8. So that's a 1 and 5/6, which is what I have up there. Example 3 is just like the lesson before. And you have 6/8 divided by 2/8. So that's 6/8 divided by 2/8. Keep, change, and flip. Multiplying straight across, you get 6 times 8, that's 48. 8 times 2 is 16. 48 divided by 16 is 3. Your proof is in the model. We have 8, so I need 6/8. So that's 1, 2, 3, 4, 5, 6, 7, 8. I only have 6 of those. So that's 1, 2, 3, 4, 5, 6 of them. I'm going to shade that in. And remember, each of these is all 1/8. And I need to see how many groups of 2/8 I have. So that's 2/8, that's 2/8, and that's 2/8. That's 1, 2, 3 of them, and that's why your answer is 3. Now, on the next page, the examples continue, but I'm not going to show you any more examples. I would like you to go ahead and solve example 2 and exercise 1. When you have this completed, please show it to me, and I will let you know if you can move on or if we need to do additional practice.